Hello, everyone, and welcome to our third aviation workshop. Today, we will be learning about RC planes, remote controlled planes. So, today, we will be learning all about remote controlled planes. And in this, we will be covering the parts of an RC plane, which are similar to parts of a real plane, the electronics behind an RC plane, and considerations while making your own remote controlled plane. So, what exactly is a RC plane? A RC, or remote controlled plane, is a plane that can be controlled by a remote controller. They have electrical parts that allow a person to fly the plane from the ground. Instead of being inside the plane, you are like a captain of the plane on the ground, guiding it through the sky with your special controller. The flyer can have the plane do all sorts of cool things, such as go up, come down, turn left, right, and much more with the correct adjustments. The cool thing is that RC planes fly just like a regular plane. So basically, it's an RC plane is very similar to an RC car because we are able to control the car with a special controller. And essentially, it's the same idea, but with planes. So here are some photos of remote controlled airplanes. As you can see in the second photo, on the right, there's a person flying the plane. So he has a controller in his hand. And this on the left, this is a another RC plane that is similar to trainer planes such as a Piper Cub or a Cessna. So now let's delve into the electronics behind an RC plane. Because after all, the electronics are the reason why we are able to control the plane's flight. So here's the list of all the main electronic components that we're going to be covering today. So we have the receiver, the transmitter, the electronic speed controller, the motor, the servo motor, and the battery. So let's get on with it. So first off, we have the receiver, and this is a nice photo of a receiver. So the receiver connects the plane with the transmitter, which is just a remote control. The receiver listens to the controls sent from the remote control and relays that information to the servo motors. When you move a joystick on the transmitter, a signal is sent from the transmitter to the receiver. The receiver then decodes this signal and then commands the specific part of the plane to align with what the flyer wants to do. The receiver can be thought of as the brain of the plane, and it physically connects to all of the servo motors on the plane. So these little connections, these spokes over here, is where the servo motors from the different parts of the plane connect. And over here is the antenna, which is how the receiver receives the signal from the transmitter. Okay, so next off, we have the transmitter. And as I said, a transmitter is very similar to a remote control that we use for remote controlled cars. And this is just a photo of a example transmitter. So we use the transmitter to control the movements of the plane. The transmitter sends signals to the receiver based on how we move the joystick. The transmitter includes the controls for the throttle, the ailerons, the rudder, elevators, and other elements that can be added. So remember, we went over these controls in our last few workshops. There are multiple different companies and types for transmitters based on your needs, such as the FlySky shown in the photo. The transmitter can do much more than just control the movements of the plane, however. Above the joysticks, over here, there are a couple of switches that can be used to toggle other add-ons, such as LEDs or landing gears for the plane to land. Okay. Thirdly, we have the electronic speed controller, ESC for short. So the ESC allows us to control the speed of the motor that rotates or controls the propeller. We can slow down or increase the speed of the propeller thanks to this ESC. It receives a signal from the receiver when the throttle stick is pushed upwards in the transmitter. And accordingly, if the throttle stick is pushed upwards, the ESC knows to speed up the speed of the motor. And if the throttle stick is pushed downwards, then the opposite. The ESC knows to slow down the speed of the motor. Without the ESC, the propeller would be spinning at a set speed, and we won't be able to change it mid-flight. Okay, so now let's move on to the servo motors. The servo motors allow us to move the control surfaces, including the ailerons, elevators, and the rudders. They do the push-pull motion. The servo motor pushes or pulls on a specific control surface depending on the signal coming from the transmitter. For example, if the elevator joystick on the transmitter is pushed down, the receiver will first decode this information, and then it'll send a command to the servo motor. The servo motor will pull the control surface so that the elevator is correctly angled as to how the flyer wanted it. So basically, it does the grunt work of pushing or pulling the specific control surfaces, and the it knows how to do this from what information it gains from the receiver, based on the information that the receiver sends to the servo motor. And servo motors are also used in remote control cars to move the wheels when we want to turn. Okay, so now we have the motor, and this motor is different from the servo motor. This motor rotates, while this servo motor just has a push or pull motion. Okay, so this motor, provides the power to spin the propeller, which creates the thrust force for the plane to move forward. And we have been over thrust force in our first workshop. So the motor gets its energy from the battery and converts it into mechanical energy in order to rotate. The speed of the motor can be changed due to the ESC. And motor size and power is very important. And they're meticulously chosen. And they're specifically chosen to create the optimal amount of thrust for the plane. And without the motor, the plane cannot be propelled forward because there's no thrust force. The motor is essentially what's generating the thrust force. And as you can see, these three wires, these yellow wires that are coming out of the motor, they connect to the ESC, which remember, help us change the speed at which the motor is rotating. And over here, this long rod coming out of the motor is where the propeller is attached. Okay, so now we have the battery, which is one of the most important components for our seaplane. So the battery is the power source that provides the energy for the motor, servo motors, receiver, and ESC so that they could all work together. The most common type of battery in RC planes is a lithium polymer or LiPo battery for short. And these batteries are rechargeable. A battery must be chosen carefully for a plane because the voltage and capacity of the battery can change the plane's flight. The battery directly connects to the ESC, which then connects to the receiver and the motor. So the battery must be chosen very carefully because we need to take into account different factors such as its voltage, its weight, its size. So it's good to know the specifications of the battery that you need. Okay, so now let's go into the considerations for creating an airplane. Firstly, you must clearly define the purpose and the type of your plane. For example, your plane could be designed for extreme high speeds, such as a jet, or it can be for quick maneuvering, like a aerobatics, or just a simple glider. This is important because it lets you pick an appropriate body shape. You also have to consider the materials that you'll use to create an RC plane. A popular and common material is a 5 mm high density foam, as it is very durable and easy to use. Another important factor is the wing design. You must design what type of wing you need, such as a flat or a dihedral wing. The type of wing you choose would impact the stability and other flight characteristics of your plane. It'll also impact the center of gravity, which is the point at which the plane is balanced. Another extremely important consideration is the electronic components you'll be using. You need to select an appropriate motor, battery, and propeller based on the plane's weight and size, and also your purpose for the plane. You should analyze the specifications of each component to find the best one for your plane. Lastly, it is also very important to test your plane before doing a complete flight. This includes ground testing, which is when you test all of the control surfaces on the ground before going into the air. Thank you for listening, and I hope this session was informative.